Hey everyone, this is Johan again. Introducing the next session. This is about LoRaWAN security. It's one of the most important technical topics that we're covering today. So as you know, Microchip and the Things Industries developed the first secure element solution designed specifically for LoRaWAN, and we launched that last year. And so what the secure element does, it's not only hardware protection against tampering, but it's also pre-provisioned, and Nicolas is going to talk about that. So without further ado, I'm happy to introduce Nicolas Demoulin. He is marketing manager of the EMEA region at Microchip Secure Products Group. Depending on the length of his presentation, we have time for Q&A. So please, Nicolas, take it from here, and thanks everyone for joining in.
Thanks, Johan. Hello, everybody. First of all, for the Q&A, please don't hesitate to post your question on the chat. My colleague Joan Pauvert will try to answer as much as possible. Hope that you guys see my screen. So here, let's go through a walkthrough of how a secure element can make easy your life for a LoRaWAN network, both on the security side, but also on the logistics side. So first of all, let's go quickly through some basics on security. So security for embedded systems are based on three fundamental pillars. The first one is authentication. You want to make sure that the object that is talking to you is the correct one and has the right to talk to you. The second pillar is about integrity. You want to make sure that the message has been sent, and when it's received, it has not been altered in the middle. Okay. And then the third pillar, which is confidentiality, is not a mandatory pillar. Okay, encryption of the data is not mandatory. It starts to be with several legislation, GDPR, UK, in California as well, but it's not a mandatory pillar to set up a secure system. Okay. So now let's move on the anatomy of an embedded system. It's smart. Okay, so it contains a microcontroller or a microprocessor, but definitely a microcontroller. It's connected, so you've got a network controller. In our case, it's going to be the LoRaWAN radio. And it can be also a combined chip like the SAM-R34, which combine an ultra-low power microcontroller plus the Semtech radio. And at the end of the day, an embedded system is secure. Okay, so it needs to contain a secure element if you really want to develop a secure system. Okay, think how is the PC market? A PC market, if you want to implement secure boot, you need to implement a TPM. It's a device which is in every PC. Okay. And it's a separated device from the host microcontroller or microprocessor. Same thing for the phone industry, the mobile industry. You've got a SIM card. The SIM card is the secure element. Okay, it's not done by the main processor, application processor. So in order to have a fully secure system, the recommendation is really to have a separate device that is handling the keys and the security. So what's a secure element? Well, it's a vault that protects the secrets. It's a companion device to a microcontroller. And the way it works is that it contains secret keys. There is a trigger from the microcontroller that sends a random challenge. The secret key and the crypto engine send back an answer, a response, that are taken by the microcontroller. This is really a high-level view. Okay. The most important thing that the secret keys, the secrets, so the keys, certificates are never to be exposed, first of all, and should not be changed at any time. Okay, so at the end of the day, a secure system implementing a secure element requires a crypto algorithm, the math, which is triggered by a key, the secrets. Okay, so. What are the best practice for key handling? First of all, don't trust human. Okay, it's the most unpredictable security risk. Human should never know the key. Secondly, you need to isolate the private keys from the software and the firmware. Okay, any unprotected microcontroller or microprocessor is hackable in any way for very low cost. You need also to isolate the key from manipulation at the manufacturing stage. Okay, whenever you are doing in-house manufacturing or through subcontractors. Then you need to keep the critical crypto primitive where the keys are. Okay, again, the keys needs to be inside the secure element as well as the crypto primitive. So now let's look at how is the LoRaWAN network topology and the key. Okay, so you've got devices, you've got gateways, you've got network server and application. Okay, and they are enabled through network session keys for message integrity, MAC command, and application session keys through payload encryption and decryption. Okay, the level of security is great. Honestly, it's great. Now everything depends on how you store the key. If it's in the flash memory, it's not well secure. If you transmit the keys to be provisioned, programmed at the contract manufacturer side through Excel or paper, it's not secure at all. Okay, so the aim is really to have the keys not known by any human and already pre-programmed, pre-provisioned at the manufacturing level of the secure element. Why that? Well, because LoRa architecture is a PS key architecture, pre-shared key. Okay, so you've got the root keys, and you need to be able to share them between the node and the server. Okay, so the question is, how can you securely distribute the share key? Okay, without sending any piece of paper, any Excel file, without that any human knows the keys. So, in terms of vulnerability today in the LoRaWAN network, you can have vulnerability at the OEM if the root keys are exposed, for sure. To employees, you again don't trust human. That's the basic of security. You can have vulnerability at the contract manufacturer. Same thing if the root keys are exposed. Okay. You can have vulnerability in the back end if you're exposed to software. Okay. And how to rekey as well. And you can have vulnerability in the end node if the keys are stored in a flash memory. Okay. So you're subject to a physical attack on the device. So you've got global limitation within the current situation. Okay, at the OEM, at the contract manufacturer, network server provider, you've got many intermediates, and you need to avoid this. So what we have done with TTI is that we've set it up a part number, a secure element that is already configured and provisioned with the keys for LoRaWAN network. Okay, so it's fully secure key storage, GIL high rated. It's already provisioned in our secure manufacturing line. Okay, it's 20 years old business to do a secure provisioning. So it's state-of-the-art provisioning at billions of units. It's bundled with a 1-year TTI joint server services. Okay, so you buy the parts, you enroll on the joint server from TTI, and you have 1 year of free services. And in addition to that, you're able to do rekeying through the TTI joint server services. Okay, so it's a fully available service from silicon to backend, including the software. Okay, so let's see the process in order to explain how we implemented this solution. So first of all, we made a one-time secret exchange of the parent keys from the joint server of TTI to our HSM. Okay. Now, thanks to the ATCC unique serial number, we are handling the derived key function in order to have unique network key and application key in the secure element. In parallel of that, we are building what we call a manifest file, which includes the serial number. And when you receive the device, you receive as well the manifest file that you just need to upload on the TTI joint server, which will in parallel also do the key derivation function in order to have the network key and application. So on a business standpoint, if you want to look at how to onboard, well, you're the customer, you buy the parts, we deliver the device as well as the manifest file, and you upload this manifest file on the TTI joint server as well as you, in order to claim the identity of your device on your joint server section. And whenever the device starts to connect on the joint server, it will set up a secure, trusted, managed authentication between the end device and the joint server. So no need to handle the key at all. So now, in terms of implementation into the hardware and software LoRaWAN stack, how does it work? So implementing a secure element is quite easy. It's an 8-pin device. You just need an I2C on your microcontroller, host microcontroller, whatever microcontroller. But then you need to have the callback function inside the LoRaWAN stack to use the secure elements. So for that, we have several implementation. For sure, the initial one and the most implemented one is the one using our thumb R34 bundle microcontroller plus LoRaWAN front end. Okay, so it's a bare metal implementation. You are using the Microchip stack, LoRaWAN stack, and everything is available. Same thing, we've got the implementation done by the Things industry on a bare metal level, which implement the LoRaMAC node stack. Okay, so still based on the SAM R34, which is a Cortex M0 ultra low power, and based on the ATCC608 TNG LoRa. And then we have a third implementation, which is based on Mbed OS, in which enable the ARM LoRaWAN stack, still on the SAM R34. Again, we are microcontroller agnostic, but the implementation has been done on the Microchip solutions. So you'll get access to all the links to first have access to the device, the secure elements, but also to all the LoRaWAN network stack. So just to show you how it works, this is the standard public web page to get access to the secure element for the LoRa configuration. Okay. This is the datasheet. So one important and interesting point is that most of the secure elements are under NDA when you want to get access to the datasheet. Here, as the configuration is already done, you don't have to perform anything on the secure element. So everything is available, publicly available. No need for an NDA with us. Then you've got access to GitHubs, which show how to implement the ECC608 together with TTI and the SAM R34 direct demo. What hardware do you need? What software do you need? You've got as well the LoRaWAN example on the TNG LoRa, okay, with the LoRaMAC node stack. And you've got a complete hands-on that you can execute yourself, workshop to implement such kind of secure implementation. Okay. So back to the conclusion on our solution. So at the end of the day, the secure element that we have implemented with TTI joint server definitely is the onboarding with security, with real security for authentication and rekeying. It comes with 1 year of joint server service included. It's robust security in the backend, so the TTI joint server is fully robust with the highest level of security on their HSM as well as Microchip HSM. It comes with simplified logistic. Okay, you don't need to transmit anything, any secret to your contract manufacturer, to your end customer. You just need to transmit a manifest file directly to the joint server of TTI, which is public information, by the way. And then on the node, well, it's robust security. So it's GIL high-rated secure elements, and the keys are definitely isolated from firmware, user, manufacturing, operators, and equipment. So it's a fully flexible and scalable solution. Please note that the secure element is available starting 10 units minimum hardware quantity for any kind of design, any kind of implementation. Okay, I think I'm done for my presentation, and I'm fully available for any Q&A session.
Awesome. Thank you so much, Nicolas, for your presentation. So we have a few questions on the chat, and we also have a few minutes left to answer those. Now, can you tell a little bit about the secure element itself? So the TNG LoRa is a pre-provisioned version of an already existing secure element, right? Can you tell a little bit about that?
Correct. So the TNG LoRa is part of the ECC 608 device family. It's a secure element for cloud application, accessory authentication, secure boot, firmware over-the-air verification. So it's a dedicated configuration for LoRaWAN. By the way, it also includes some certificates, Microchip certificate for cloud onboarding. So we can do as well LoRaWAN onboarding, secure authentication, as well as standard TLS cloud authentication like Azure, AWS, or Google Cloud, or any private cloud.
So it's a secure element. So you get all the benefits of a secure element, and also hardware acceleration for cryptographic operations and things like that. But this particular version is also pre-provisioned.
It is, and this is what is the most difficult operation to do when you implement a secure element. Again, hardware and software standpoint, it's really easy. But now, when you need to do the configuration and when you need to do the key provisioning, this is where it costs hundreds of dollars for one project. So here we come with a fully personalized solution. Configuration is done, provisioning is done with 10 units minimum order quantity at really low cost. This is an awesome solution to start with real security without having the need to understand what is security.
Yeah. Okay, cool. We have a question from Paul Hayes, and he asks, so how do you handle the manifest files securely? Because there's a human element again, right? So you have a file. So can you tell a little bit the difference between the manifest file or what's in the manifest file as compared to, let's say, a Excel file with app keys?
Sure. So the manifest file does not contain any secret, any keys, any private information. It only contains the serial number, which are public information. Okay, it's like when you have your passport, you've got a unique number on your passport. Everybody can see it, but nobody can get use of it. So whenever you receive the manifest file, you'll be able to upload it on the joint server, on TTI joint server, but there is no confidential information into this manifest file. So keys are not exposed to human. No confidential information is exposed to any human within the manifest file.
Yeah. Indeed. What's to add there is that the manifest file is also signed by Microchip, so that you cannot create your own manifest file and start claiming devices that are not yours, right? So it's a serial number and it's a signature.
Correct.
A question from JP Myers about power consumption of the secure elements. Can you tell something about that?
Sure. So in sleep mode, we are down to 150 nanoamps maximum. So it's like 85 degrees operation. It's hard-coded secure element. So the power consumption is really optimized for IoT and battery-powered objects. So it's not a microcontroller, secure microcontroller running. It's hardware state machine that is handling the encryption algorithm and the keys.
Okay. Great. Can you stop sharing your screen in the meantime?
Sure.
That's for the studio. And a follow-up question from Paul about the secure exchange. So and I think I can answer this also, but please answer also your side about the key exchange. So how does it work if the manifest doesn't contain any keys? How does Microchip and the Things Industries know what the secret app keys are?
So again, the implementation we made was based on a master parent keys, okay, that we both have in our HSM, so TTI and Microchip. And from the serial number, we are able, and from some other information which are internal of the secure element, we are able to derive the unique network key and application per secure element. Okay, so nothing is, again, no confidential information is transmitted in the manifest file, but our both joint server and HSM organization are able to generate the device unit network key and application key.
Cool. Then last question from Jack about how to use it on the community network, and I can answer it for you, Nicolas, is that currently we don't have the joint server support in the V2 community network available, but we have it in V3 cloud hosted. Please contact us if you want to get started with that already. But we plan to migrate the community network to V3 in the coming months, so you can use this solution also in the free community network. So there's no additional subscription or cost associated with it. You get 1 year of joint service for free when you buy the device. So with that, we'd like to thank you very much, Nicolas, for your presentation. And I'll hand it over back to the studio. Thank you very much for joining.
Thank you, guys.